Although the Earth seems to be quite a stable and solid entity, the tectonic plates that make the Earth's crust are in constant movement. When these huge plates move towards, past, or away from each other, they create friction which causes these plates to get stuck. The energy stocked between plates is released through seismic waves, which creates ground shaking on the surface. Mexico sits at the top of the three of the largest tectonic plates: the Northern Plate, the Cocos Plate, and the Pacific Plate. In this challenge, Mexico's 2017 earthquake was chosen as a case study because of its big impact on the city of Puebla. The 7.1 magnitude earthquake caused immense damage, killing 370 people because of the failure of different structures. Engineers have to work to avoid tragedies like the 2017 earthquake. Structural engineers have to reduce the vulnerability of the built environment by understanding the different loads and hazards the building will have to resist under an earthquake. These hazards are ground shaking and surface rupture, landslides, liquefaction, and tsunamis. To minimize the risk of these hazards, engineers have to follow a certain design criteria to ensure the construction of a resistant structure such as the one we built in our workshop, which we based on a specific yellow building in Mexico that failed due to the earthquake. This design criteria starts with choosing a safe site with low risk of landslides and liquefaction. They have to use cross-braced frame to reduce the impact of lateral load on the building. Engineers have to make sure that there are no irregularities in height and weight to avoid concentrated stress and soft-story failure. Strong connections between elements in the building is also essential for a resistant structure. Engineers designed the building to fail in a controlled way by using ductile materials instead of brittle ones and creating an evacuation system. This reduces the cost and increases the chances of survival of the people. Geotechnical engineers analyze slopes to propose safe inclinations for structures in high earthquake risk areas to avoid landslides. After finding the angle of repose for different horizontal acceleration in our workshop, working with rice to represent granular soil, we plotted a graph of the angle of repose over the horizontal acceleration to find the friction angle for the peak acceleration of the Mexico earthquake. We can then find a safe inclination at around 20 degrees for a factor of safety 1.5 by using the equation in step 1. Engineers play a crucial role in the safety of cities, especially ones that are highly seismic. In this challenge, we looked at a high-magnitude earthquake in Mexico that affected many people's lives because of the poor designing of structures. To avoid such collapses, the buildings in Mexico have to be built following the design criteria mentioned earlier and also have to be built on an inclination of around 20 degrees for a safe resistance to extreme horizontal loads like earthquakes.